All right, group number 2. A rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by our equation. All right, we need to go ahead and get a table so that we can graph some points. So we're going to go to Desmos and put in our equation. Make sure you're using x instead of t. Okay, and we created a table here. So 0 corresponds to 80, 1 to 128, 2 to 144. I'm going to add some more points here. 3 is at 128. 4 is at 80. And 5 is at 0. Okay, so part A says, what is the height of the rocket after 1.5 seconds? Well, that's not something that we can see here. So there's 2 different ways that we can handle this. We can plug it into our equation. Oops. Okay, and we can put it in our calculator, get an answer, or we can go into our table in Desmos and type in 1.5 and it'll tell us 140. However you prefer to do that is absolutely fine. Forgot to label height in feet, time in seconds. Okay. What is the maximum height reached by the rocket? That's this point up here, which was, pull it back out, 144. So that height is the 144, or the y value. How long will it take for the rocket to hit 128 feet? So it starts at 80. The first time it hits 128 is right here after 1 second. After how many seconds will the rock hit the lake? It starts here at 0, right? Gets its peak, and then it hits the lake after 5 seconds. Then it says find f of 4 and interpret the context. So we have 2 different ways of doing this. We can plug it into our equation, of course. Or we can just go straight to our table. 4 corresponded to 80. And this would be in feet. So what does the point 480 mean in context? This means that when the rocket is has been in the air for 4 seconds, its height is 80 feet. After being in the air 4 seconds, the rocket has a height of 80 feet.